try to do this one. So I'm like, if f of x is equal to the 3x cubed, what is its derivative? Can you try to prove this?
Yes.
Like, I'm not asking you, can you do this? I'm asking you to do this. Well, we're going to use the same formula. It is going to be f of, or limit of h goes to the 0, f of x plus h minus f of x divided to the h. And this is equal to the limit of h goes to the 0, 3 times 2 x plus h in the cube minus 3x cubed divided to the h. And if you remember what is the formula of the cubic formula, then this is good. If you don't, it's okay. So it is going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus 3x cubed divided to the h. Then I'm going to again cancel lots of things here, right? So I can cancel, for example, this 3. Oops, sorry. I cannot cancel this 3. I can cancel x cubed, 3x cubed with a 3x cubed. I can cancel with this h, this h, this h, and this h. And what I will have here is the limit of h goes to the 0 of 9x cubed plus 9xh plus 3h in the square. So this is going to be equal to the 9x squared as h goes to the 0. Okay, I think it is not so difficult for you, right? So I think we're ready to prove the derivative of the x in the power of n. Okay, let's do this. X in the power of n.
You did it by yourself.
Huh?
You did it by yourself.
By myself, yeah. Okay. So the derivative of this function is going to be again f of x plus h minus f of x divided to the h as the limit of h goes to the 0. Okay? So first of all, I'm going to evaluate what is the f of x. It is going to be simply x in the power of n. What is the f of x plus h? X plus h in the power of n, right? Can you expand this, by the way? Yeah? How we can do this? The binomial formula? So it was like the summation of, right? C, n, k. K goes from 0 to the n. Do you remember this? No? So x in the power of, let's say, k, and h in the power of n minus k. Okay? Yeah? It's okay if you don't remember. Now you know this, right? So I'm going to show it quickly, for example, for the case of 2. Okay? So let's say n is equal to the 2. Let's say n is equal to the 2. Then what is the x plus h in the power of 2 using this formula? It is going to be the summation of k goes from 0 to the 2, c to k, x in the power of k, h in the power of 2 minus k. Okay? So I hope that you still remember how the sigma notation works, right? Sigma notation. So essentially, it is very much similar to the for loop. Okay? You're going to make the summation, right? You remember for, like a k from 1 to the n, right? So you're doing k, for k from 0 to the n. Okay? Do you remember what it does? So every iteration, it just simply adds 1 to the value of the k. We're doing the same, okay? We're going to start from the k is equal to the 0. If you substitute k is equal to the 0, what you get? C, z, 2, 0, x in the power of 0, h in the power of 2. Right? If you substitute k to be equal to the 1, what you get? C, 2, 1, x, 1, h, 1. If k is equal to the 2, what you get? C, 2, 2, x to h 0. Okay? So then we just need to sum this because there is a sigma notation here. Then we're going to evaluate the c to 0. It is going to be equal to simply 1 times to the 1, because x in the power of 0 is 1, times to the h in the square, plus c to 1 is, like, I'm going to remind you what is the c and k one more time. So n goes up, k goes down, right? Then I just need to also multiply this as the difference of the n and k to the factorials. Okay? This is going to be equal to the 2 goes up, 1 goes down, then 1 goes down. Okay? So x in the power of 1, h, plus, so c22 is also 1. X in the square times to the 1. It is going to be h in the square plus 2xh plus x in the power of 2. Okay? Which is indeed is true. Okay? So this binomial formula actually helps us to do this for any power of the x plus h. Okay? So now I'm going to just apply this for a couple of first terms of this function. Let's do this. Oh, can I change this like this? N minus k and k. It is going to be true anyway. Okay. So let me do this now. Okay, so I'm going to open the brackets a little bit. So for first couple of terms, it is going to be c n 0, x in the power of n, h in the power of 0, plus c n 1, x in the power of n minus 1, h in the power of 1, plus c n 2, x in the power of n minus 2, h in the power of 2, plus and so on, plus h in the power of n at the end. Okay, so you see, so we always start with the x in the power of n, always, right? Because this is equal to the 1, this is equal to the 1. Okay? And we end up with the h in the power of n, always. The second term here is, can you help me with the cn1? N goes up, right? N goes up. So n goes up, 1 goes down. What else is going up, down? N minus 1, right? N minus 1 factorials. It is going to be x in the power of n minus 1 times the h. Okay? Can you help me with these terms? I don't need to open this because it is going to be cancelled out. You will see this in a moment. So an h squared plus and so on plus h in the power of n. Okay? So do you still remember what is the derivative of the function? Derivative of the function is the limit of the difference of these two things. So x plus h minus f of x divided to the h, where h goes to the 0. The difference. Okay? If you just look to this last line, and if you find the difference between these two things, say like a 2, let's say, minus 1. Like a 2 minus 1. So and I hope that you understand that I'm not subtracting 2 minus 1, right? I'm subtracting the expression which is called as 2 minus the expression which is called 1, right? If you subtract, what is left? So if you subtract them, what is left is h goes to the 0. So only the first term and this first term are going to be cancelled out, right? And the rest is going to be left. It is going to be, by the way, do you know what is the n factorials divided to the n minus 1 factorials?
It will be
N, right? So we know that, for example, 5 factorials divided to the 4 factorials is 5. Because 5 factorials is 4 factorials times the 5.
Yes.
Right? Okay, so that is why it is going to be n times to the x in the power of n minus 1 times the h plus cn2 x in the power of n minus 2 h squared plus and so on plus h in the power of n. All of this divided to the h. And then we're going to, so you see, so all of these terms on the numerator have the h. And I'm going to divide every term on the numerator to the h. And I will obtain the limit of h goes to the 0. So n times the x in the power of n minus 1. Plus cn2 x in the power of n minus 2 h. Plus and so on, plus h in the power of n minus 1. So all of these terms except the first one is going to be 0 as h goes to the 0 because all of them have the h. And what is left is n times the x in the power of n minus 1. Okay, this is the formula which we use always, right? And this is like a fascinating formula because it helps us to understand what is the derivative of the power functions with the rational powers, with the negative powers, and so on. Okay, so the derivative of the f of x, x in the power of n, is equal to the n times the x in the power of n minus 1. Okay? Cool. So today we discuss about the horizontal asymptotes, the vertical asymptotes. We also discuss about the connection between the limits and the derivatives, right? So as we are going to go through these lectures, we are going to discuss about the official derivatives. We're going to prove the formulas for all of the functions. The trigonometric functions, the exponential functions, okay? So in our next lecture, which is going to be on Wednesday, which is going to be the lecture 5.1. This is the lecture 4.2. Okay, it is going to be offline for the group 1, and you should watch this online before coming to the lecture because I will ask you the questions, okay, during the lecture 5.2. Cool? Good. Thank you very much for your attention. See you next week.